Okay, Smith and Blue kids, make sure you're following along with the guided practice. Feel free to pause the video as necessary. Today we're going to be looking at tree diagrams and sample spaces. We've talked about sample spaces before, but not necessarily tree diagrams. So tree diagrams are a visual representation of all of your possible outcomes in a probability experiment. So our first example here, we have a spinner with A, B, and C, and it says the spinner is spun twice. So we're going to create a tree diagram. So what happens is we have to figure out how many possible outcomes are on this spinner, and we have 3. So we're going to create 3 branches and label them each section of the spinner, A, B, and C. That's for the first spin. Then for the second spin, if you say you get A the first spin, then you have 3 outcomes for your second spin, A, B, and C. You'll do the same thing. If you get B the first spin, you could get A, B, or C on the second spin. And then if you get C on the first spin, you could get A, B, or C on the second spin. So that's the tree diagram. We're also going to list out what our sample space would be. So our first outcome would be if we land on A, we could land on A again. Our next, if we land on A, we could land on B the second time. And then after that, it would be A and then C. If you got B the first spin, you could get A on the second spin, or you could get B and then B, or you could get B and then C. And then our last set of outcomes would be C and then A, C and then B, C and then C. So on our first spin, there were 3 possible outcomes, A, B, or C. On the second spin, there were also 3 possible outcomes. To find the total possible outcomes, we want to multiply those, which means our sample space should give us 9 total outcomes. Now we're going to use the sample space to find the probability of each. So A, it just says probability of twice. So we're going to say B twice. What is the probability of getting B and then B? So here is my sample space, and there is only one outcome in which you get B and then B. So that would be 1 out of 9 possible outcomes. That doesn't simplify, so that's your answer. Our next question here says probability of at least one A. So again, I go and I look at my sample space, and I would need to know anytime an A comes up. And there are 1, 2, 3, 4, 5 possible outcomes there. So the probability of getting at least one A would be 5 over 9. That does not simplify, so 5/9 is my answer. And then the last one says the probability of no C. So we want to not get a C. So you can either cross off any of the ones that have a C in it and figure out how many are left over, and you would have 4 that are left over. So that's 4 outcomes out of 9. That also doesn't simplify, so that's your answer. Okay, we're going to go to our next example. But this time we're choosing for ice cream flavors and their toppings. So I'm given 2 ice cream flavors, vanilla or chocolate. I'm going to set my tree diagram up a little different. Instead of sideways branches like on the first one, I'm going to do branches that look like this. And then you would have vanilla and you would have chocolate. So I have 2 options for ice cream flavors. Once I pick an ice cream flavor, I then choose one topping. So if you choose vanilla as your ice cream flavor, then you have 4 options for toppings. So I need 4 branches, and then I would label each: sprinkles, peanuts, granola, M&Ms, and it's definitely okay to abbreviate on these. If I didn't choose vanilla and went with chocolate, I would still have 4 outcome options for toppings: sprinkles, peanuts, granola, and M&Ms. So from here, I'm going to list out the sample space, a list of all of my possible outcomes. So I'm going to start with, I could have gotten vanilla with sprinkles. I could have gotten vanilla with peanuts. I could have gotten vanilla with granola. I could have gotten vanilla with M&Ms. So again, I'm just abbreviating here. If I had gone with chocolate instead, I would have gotten chocolate with sprinkles, or chocolate with peanuts, or chocolate with granola, or my last option would have been chocolate with M&Ms. So for my first options, I had to choose between 2 flavors. For my second option, I had to choose between 4 toppings. To find total possible outcomes, I would multiply those, which would give me 8 total outcomes. We're going to use that sample space to find the probability given for each A, B, and C. Probability of chocolate first. So you would go through and figure out how many outcomes offer chocolate. There are 4 out of 8 total outcomes. Now this does simplify, so I'm going to divide both the numerator and the denominator by 4 to get 1/2. Next, I want probability of M&Ms. I have 2 options that include M&Ms. So that would be 2, and my total would be 8. That also simplifies. I can divide my numerator and denominator by 2, and that leaves me with 1/4. And then my last says vanilla with sprinkles. There's only 1 outcome that gives us vanilla with sprinkles. So I would have 1 out of 8 total outcomes, and that is as simplified as it gets. Hopefully you get the process, but I'll go ahead and do one more example. This, we have a day of the week is chosen. Keep in mind there are 7 days of the week, and then a coin is tossed. There are 2 sides on a coin. Be thinking about how many total possible outcomes would that give us if I use the same process as I did on examples 1 and 2. So here, I'm going to write out my days of the week, which means I'm going to need 7 branches. 1, 2, 3, 4, 5, 6. Let me go ahead and reset. 1, 2, 3, 4, 5, 6, 7. That gives me a little more space. My first day of the week, Monday. Then Tuesday, I'm going to write TU. Then Wednesday. Then Thursday, TH. Then Saturday, forgot Friday. Friday, Saturday, and then Sunday. So those are the days of the week. Then we're tossing a coin. There are 2 sides on the coin. So now I need 2 branches off of each of my days of the week. I've got Monday, heads, Monday, tails. Tuesday, heads, Tuesday, tails. Wednesday, heads, Wednesday, tails. Thursday, heads, Thursday, tails. Friday, heads, Friday, tails. Saturday, heads, Saturday, tails. Sunday, heads, Sunday, tails. And then I'm going to actually list that out as well. So go ahead and list yours out while I'm listing mine, and then just kind of check back and forth to see if they match. And then my last one. So we had 7 days of the week. That was the first experiment, days of the week. There are 7. Our second was tossing a coin. There are 2 sides on a coin. Your total possible outcomes should be equal to 14. So you would go back and just make sure you have 14 numbers. 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Here we're looking for the probability of getting tails. So if you went through and figured out for tails, that's going to show up 7 times out of the 14 possible outcomes. That simplifies. I can divide them both by 7 to get 1/2. B, a day that starts with T. So I would go through and circle all of the days that start with T. So I've got a Tuesday, a Thursday, so that would be 4 outcomes out of 14. That simplifies as well. I can divide them both by 2 to get 2/7. And then the last one says Friday and then heads. There's only 1 outcome, so that would be 1 out of 14. That does not simplify. So that's a breakdown of tree diagrams, sample space, and then using the sample space to find a probability. Last thing is called the fundamental counting principle. Very easy, very straightforward. It just says if one activity can occur in, and we'll just say 3 ways, and the other activity can occur in 4 ways, then both activities can occur in 12 ways. And the way that we get that 12 is we multiply your possible outcomes for each event. So we had a 3, we had a 4, we multiply, and we would get 12 total outcomes. So for our examples here, all you have to do is to determine the number of outcomes for each event and then multiply. So if Karen, to leave her office, Karen can choose between 3 sets of stairs. So that's 3. And 7 doors. That's 7. How many ways can she leave her office? All we have to do is multiply those to get 21 ways. A dinner menu consists of 5 appetizers, 12 entrees, and 3 desserts. How many ways can someone order 1 appetizer, 1 entree, and 1 dessert? So all we need to do here to find our total possible outcomes, multiply our 5 by our 12 and our 3 desserts. 5 times 12 is 60, and 60 times 3 is 180 options. And then last, a quarter is tossed, and then a letter from the word, typo there, snowflake is chosen. How many outcomes are possible? So we need to know there are 2 sides on a coin. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 letters in the word snowflake. 2 times 9 gives us 18 possible outcomes. You're going to use the rest of the time to work on your independent practice, which is on the back. Please use the Desmos to check your answers for the probability questions. You'll need to draw out your tree diagram and list your sample space, but for the probability questions, those are coded in Desmos. Be good for your sub. Have a good